Yeah, let's see if the mic. Everybody can hear me?
Yep.
Yes, great. Yes, I want to welcome you everybody to my first Cocoa Head meetup. I start this by signing up as a presenter, which maybe we'll see how it goes. Wish me luck. So I want to present to you some work we have done with Apple Vision Pro and how we can build a full-scale car model app. And the idea here is after this presentation, you will be able to go home and try this yourself. Maybe if you don't have a Vision Pro, you can do it in the simulator. And the idea here is that we will create a full-scale car model app in which you can display amazing detailed car in your very own living room. But first, brief introduction of who I am. My name is Patrik Lundqvist. I am an iOS developer here at Umain. But recently I was a student at KTH working on a master's in interactive media technology with a focus on extended reality. I worked on my thesis in collaborations with Umain, in which I did research with the Vision Pro and ended up here as a Swift developer. And to wake you all up, I have included a very bright picture next, so you have been warned, and here it comes. There we go, everyone has woken up. So this is just a quick sketch I made to get everyone idea what we are planning to build here. Just a quite simple Vision Pro app in which we will display, of course, a Volvo car in front of the user using the Vision Pro. But first, we will first have a brief overview of the Vision Pro itself. An amazing feature with the Vision Pro is its micro OLED, almost 4K displays per eye, which gives it a very high fidelity when it comes to rendering 3D modules. I can share you that some colleagues of mine who have been working with virtual furnitures have maybe dropped some coffee cups thinking it was a real table when they placed down the cup working on the code. What enables this device a lot is its 6 tracking cameras, which is used to track the world around it and the objects in it. It is also with these 6 tracking cameras that we enable hand tracking, which is a feature of the Vision Pro. We have also 4 cameras inside the headset looking at the eyes, enabling high precision eye tracking. And all of this is powered by Apple's M2 and R1 chip, which works together to render this at runtime. And then for the tech stack, I think Xcode and Swift UI, some of you have heard about, but maybe not everyone has heard about Reality Kit and AR Kit and Reality Composer Pro. These frameworks makes it quite streamlined to develop for the Vision Pro when it comes to native development. So I want to talk a little bit more about Reality Kit, which is an AR first 3D framework, but it has capabilities for VR as well. So what is AR? AR stands for augmented reality, in which I would define as adding 3D virtual elements to the real world. So you would be able to see your surroundings and have some augmented elements to it. And then we have VR, virtual reality, in which the user is fully encapsulated in a virtual environment. With Reality Kit, we can build and modify 3D scenes at runtime with Swift code. We can have virtual objects interact with the real world, and we can use it to animate both manually and using simulated physics. And all of this is perfect for Vision OS, but Reality Kit has also features for iOS, Mac OS, and iPad OS. It is based on a previous older framework called ARKit, but it doesn't migrate all the features from ARKit, which means for some specified situations we need to use ARKit, which we will demonstrate in this app. today, but I will talk more about ARKit later. And then we have Reality Composer Pro, which is a 3D editing software. And with this, we can use to visually design, we can edit and preview 3D assets. But it is only for visionOS, sadly, thus far. But I will also dig deeper into Reality Composer Pro later. So we want to look into how to set up your own project. But before we can look into code, we need to understand the fundamental view structure of a Vision Pro app, which is looking like this. So we have 3 different immersive elements. The first one is a window, which I would describe as your basic screen, like a Mac screen or a iPhone screen, which has the same functionality as a screen. You can use it to display UI elements and interact with them. Then you have a volume, which is very similar to window, but you add another dimension, which is primarily used for like low fidelity 3D assets, which inherits the functionality of the window. So you can scale it and you can like move it around your environment, similar like you can do with a window. But if you want to unlock more of the user's environment, you have to use an immersive space. And this is where we have our AR and VR functionalities. So on visionOS, AR is defined as mixed, and VR you will use full VR. And then you have also third mode, progressive, is in which you can like with code or let the user change between them with the percentage. So understanding this, we can now jump into some code. So this is the main app structure, which you can pretty much recognize with a window group and a content view. I have just defined a basic button in the content view. And then we have defined this with a window style and plane. That's just your basic screen. Then we have the immersive space with an ID, which I use to reference with the button in the content view to open it. And here we also have to select the immersive style. And here I have decided to use mixed, which was AR. We also have a state variable called style, in which we can, with code, change it while the user is using the app. But now it's just fixed to mixed. Digging deeper into the immersive view, and this is the skeleton code for your reality view. So here is where we import RealityKit. We have a reality content, and that's the 3D assets that you have in Reality Composer Pro. You define a reality view. You try to load it, and if you succeed, you just add it to the scene. It's that simple. So we will try this now. Yes, it works. And here we have our plain window with a button. We press it, and it should load our 3D assets. Yeah. Yeah, this is just a basic 3D sphere. But we maybe want something more, a little bit more advanced. And here is our where our user interactions come into the picture. So as I said, we have eye tracking and hand tracking. Vision Pro does not support your classical VR controllers. Instead, relies mainly on using your eyes as a cursor to select different UI elements or 3D assets in the scene, and then using hand tracking to interact with them. And the basic hand tracking gestures you can use is pinch is to select, like your mouse click. You can also use rotate. You can grab the objects. You can also make custom gestures. But we will keep it simple and we will first start with how to enable feedback for 3D assets, in which we just go back to our immersive view. We will initialize an input target component, which tells the code this can be used as an input. And then we add a hover effect component, and then just set it to the entities components list. And then rerun the code, and it should look like something like this. Oh, amazing, it works. So it will just highlight the object, indicating that the user can do something with it. So I think it would be funny if we could just maybe use our hand to move the object in the immersive space. And for that, we will define a drag gesture, in which would be selecting object and then moving your hand. We first need to make a target for this gesture, and because we only have one asset currently, I will just target it to any entity. And then when the value of the gesture changes, we will take that location data of our hand and just set it to our entity, mimicking our movements. And it should look like something like this. And this is very basic how you would create interactive apps in Vision Pro using Swift code. But we maybe want something more advanced. We were talking about a car. That's where we go back to Reality Composer Pro and take it into our hearts. So as I said, we design, we edit, and we can preview 3D assets. We can also here edit components and create animations with timelines. And I think, yeah, this is a great feature because for me it's more intuitive to see the assets I'm working with and what happens instead of relying on just pure code and trying to read out what's going to happen. And Reality Composer Pro uses the USD format, the Universal Scene Description, which is a format started by Pixar after they had some hard lessons from the first Toy Story movie working with 3D assets. And the idea behind that is to streamline the development process with 3D assets. And one of my favorite features is that it enables multiple developers to work on the same scene without having conflicts. I have had a lot of experience working with Unity, changing one color of architecture, and then the whole project conflicts, almost starting all over again. And now we have a car, we have some interactions, and we can look at what we have. I will ask my beautiful assistant to come and help me. Robin, you work too?
Yes.
Thank you, thank you. So we will quickly change computer, make this as painless as possible. So here is the Vision Pro hidden. We'll jump into it. I will try to share what I see. I'm finding Robin's MacBook. There we go. There we go.
Hello.
And now we should see what I'm seeing. Perfect. So I will try to move as little as possible. It's very unintuitive to have like a camera strapped to your face. So I will first try to open the main menu, and here is where you will be able to select different apps. I can use hand tracking, and I can also use like physical touch to select. And here we have our app we built previously. With a basic view we have here, it's like anchored to my environment. Very, very hard anchored, which shows the impressive tracking the Vision Pro has. I will look at the button and I will open immersive, and there we have our Reality Composer Pro assets spawning into the room. So here we have the car moving unnaturally slow, trying to minimize the shakiness. So here we have the car model in the room. You can see the highlight effect where I'm looking. The Vision Pro also uses foveated rendering, which means it focuses the rendering on where I'm looking. So we get the crispest view where I'm looking. I will move slowly. And I'm waving. Oh! Yeah, we enabled interactions with the car, so we can just look at the car and we can pinch it and we can drag and move it around, place it wherever we want. Maybe on the audience. Perfect, balanced. So yeah, some of you will be able to try this after this presentation if you want to. And that was the demo of this app. Yeah, and there's more. Amazing. See if this works as it did previously. It did not. So I will have to start the screen recording again. So file, new screen recording. This is dedication. Record display 1. Perfect. Restarting the presentation. Hope everyone is having a great time. There's more drinks, I think, I hope. Or am I just lying? Wi-Fi is very slow right now. Always nice with some demo ghosts. Nice to see them. And there we go. So yeah, that was the demo. And we're back on track. So another amazing feature I find with this is that we can access the tracking data while users are using the app, which can give us powerful insights on how we should design our apps. So when someone is using Division Pro, it assigns transform matrices to elements in the environment, which contains the positional information and the rotation information, among other things. And as an example, using hand tracking as an example, we can access these transform matrices from individual joints all over the hand, giving us a deeper insights in how people are acting when using our apps. Sadly, we have no access to the tracking data. Apple has blocked that due to privacy concerns, which is sad but understandable. So now I want to go into a bit on how we use ARKit to unlock this positional data. So we go back to our immersive app here, and we add some we import ARKit. We add an ARKit session, a world tracking provider, which gives us the device location in our app. And then we will want to store it somewhere, so we add a device matrix with the timestamp and when we tracked, and the transform matrix itself. And then we set up a task for the immersive view. So when we open it, we want to try to run our AR session with the world tracker. When that succeeds, we will try to run at an interval. Because we don't want to clog up the app with just taking measurements all the time. So we will set a frequency, how often we want to save this data. For this lighter app, I have set a frequency at 90. This can be lowered for more high-end apps. And at the frequency, we will run this function, which I will go more into here. So here we have the run at interval, which will just use a simple task.sleep to pass the code and then run the function. And here is the function which we use to get our data. We will take the timestamp when it happened, check if we have the world tracker is active. Then we will, at the timestamp, get the data from the device anchor, take the device anchor, get the transform matrix, and then just append the data to our list. And this is the result from a very similar app, like this one I displayed today. With this, we can see to your left side, we have a 3D graph of the data with the positional data and the timestamps. And then this is the same data, but as a 2D graph to give a better oversight. We have also colored the tracking points based on time. So from this data, we can see in the beginning of the app, there's like darker blue areas, and then in the end, we have yellow. From this, we can read that the user tended to be in front of the car, looking at the driver's seat and passenger seat, and then start to move behind the car and look at other interiors. So interesting with this is how scalable it is. So this is another example of this tracking data. But this is a person using the device and walking around the whole office with some side steps here, and that's where the toilet in this building is. So now you know that we are here, we have toilet there, and we have toilet up there. For some reason. Another interesting thing we did with this, last autumn we did some user testing with a similar app, like the one you saw, but more features. And we gathered the data of 10 different users interacting with the app. Then we just did a histogram in which whenever a person entered a pixel on this graph, we highlighted that pixel a little bit. So from this, you can see that people tended to hang out here a lot. That could be because we put the menu here, the window, to interact with the car. And then people tend to hang out around the doors and in the driver and passenger seat and on the sides, and not so much behind the car. And what I find from this an interesting insight is that people don't tend to walk through the car to access, even though they could. They prefer to walk and enter the car through the actual doors, which could indicate on how immersed they were when using the app. So with this, we can get some powerful insights in how people use and interact with our apps. As we can see, people tend to be around the driver's seat, so maybe that's where we want to focus our intention when coming to developing the app. Or if there's some features we want to show in the backend, we might need to focus more on how to get their focus on that part of the app. And that was some insights, and that's sadly time up for me. Yes, if you have any questions, I would love to take them. Perfect. Crystal clear. Perfect. Thank you.
Thank you. That was a perfect one. Such apps give me hope that one day I will learn how to parallel park. But
This
it's
is
not for the future.
perfect. Perfect use case.
Thank you everyone for joining us today. It was a very good evening full of insights and inspiration. Don't forget to chat, connect, and mingle a little bit after this. And don't forget that the doors will be closed at 9. And we will be waiting for you next month for our next meetup. It will be on April 7th. Don't forget to connect and follow for new updates. Thank you.